June 24th, 1944. D-Day +18. The Norman Bocage, 3 miles southeast of Saint-Lô, France. Sergeant Curtis G. Culin, Jr. of the 102nd Cavalry Reconnaissance Squadron, crouches beside his M5 Stuart light tank in the suffocating heat of a French summer afternoon. The air hangs thick with the sweet-sour stench of decomposing cattle, cordite, and something else, something distinctly human. Around him, the ancient landscape of Normandy has become a killing field unlike anything the American military planners anticipated. And Culin, a 26-year-old cab driver from Cranford, New Jersey, is about to solve a problem that has stumped generals, colonels, and the entire engineering corps of the Allied Expeditionary Force. But he doesn't know that yet. Right now, he's just furious. The hedgerows, the damned hedgerows. Nobody told them about the hedgerows. To understand the revolution that Culin is about to unleash, you must first understand the bocage. For 1,000 years, the farmers of Normandy have divided their fields with living walls of earth, stone, and vegetation. These aren't the tidy English hedges that Allied planners studied in reconnaissance photographs. These are ancient fortifications of nature, earthen berms 4 to 6 feet high, crowned with centuries-old root systems that have woven themselves into nearly impenetrable barriers. Oak, elm, hawthorn, and blackthorn grow from the tops, their roots binding the earth into something approaching concrete. Some of these hedgerows date back to the Roman occupation of Gaul. Others were planted during the medieval period, marking property boundaries that have remained unchanged for 500 years or more. The result: walls 12 to 15 feet tall, 3 to 4 feet thick at the base, completely opaque, and absolutely impassable to standard military vehicles. The hedgerows create a maze of staggering complexity. Each field, rarely larger than 200 yards on a side, becomes an isolated killing zone. The sunken lanes between them, worn down by centuries of cart traffic, become natural trenches deep enough to conceal an entire infantry squad. For the German defenders of the 7th Army and 5th Parachute Division, the bocage is a gift from God. For the advancing Americans of Bradley's 1st Army, it's a nightmare that's turning their material superiority into a cruel joke. The intelligence failure that led to this situation deserves examination. Allied reconnaissance had photographed Normandy extensively in the months leading up to D-Day. The hedgerows were visible in these photographs, certainly, but aerial reconnaissance has limitations. From 5,000 feet, a hedgerow looks like a thin line separating fields. There's no way to judge the height, the thickness, the density of the root systems. The photo interpreters, working in England, made assumptions based on their own experience with English hedges. They assumed these were similar features. They were catastrophically wrong. The pre-invasion briefings mentioned hedgerows in passing, as minor terrain features that might slow armor slightly. No special training was provided. No doctrine was developed. The tank crews trained in England on open ground. The infantry practiced assault tactics in fields without obstacles. Everyone assumed that once the beaches were secured, the advance inland would be a matter of superior firepower and numbers overwhelming a retreating enemy. They assumed wrong. Here's what happens when an M4 Sherman tank attempts to cross a hedgerow using standard doctrine. The driver approaches at an angle, attempting to climb the earthen berm. The 33-ton tank tilts upward at 45 degrees, sometimes more. The Sherman's center of gravity shifts dramatically. The tracks on the front bogies lose contact with the ground, reducing traction by nearly 50%. The relatively thin armor of the Sherman's belly, merely 1.5 inches of rolled homogeneous armor, becomes exposed to any German anti-tank weapon in the field beyond. But that's not the worst part. As the tank crests the hedge, the gun mantlet tilts skyward, the barrel pointing uselessly at the clouds. The gyroscopic stabilizer, which allows the Sherman to fire on the move under normal conditions, cannot compensate for this extreme angle. The driver is blind, his periscope showing him nothing but vegetation and sky. The bow gunner can see nothing. The commander, standing in his hatch, becomes the only crew member with any visibility, and he's completely exposed to small arms fire. For 5, perhaps 10 seconds, the Sherman is completely helpless. That's when the German gunners fire. A single Panzerfaust, the disposable-shaped charge weapon that costs the Wehrmacht approximately 5 Reichsmarks to manufacture, can penetrate 5.9 inches of armor at 30 meters. The weapon is crude, almost primitive in its simplicity. A steel tube, a shaped charge warhead, a propellant charge. A Hitler Youth member can be trained to use one in 20 minutes. But in the Bocage, it becomes the equalizer that allows a single German soldier to destroy a tank that cost the United States $45,000 and took 6 months to build. The grenadier waits in the shadow of the opposite hedgerow, perfectly concealed in the undergrowth, perfectly positioned. He's been there for hours, perhaps days. He knows this field intimately. He knows where the Americans will cross. He aims not at the glacis plate, which on later models Shermans can be nearly 4 inches thick, or the turret, which is heavily armoured. He aims at the exposed underbelly now silhouetted against the sky. The warhead strikes. The molten jet of copper, travelling at 20,000 feet per second, punches through the floor of the tank. What happens next defies easy description. But survivors have tried. The Sherman's interior becomes a furnace. The shaped charge doesn't just penetrate, it creates a spray of molten metal that ignites everything flammable inside the fighting compartment. Hydraulic fluid for the turret traverse catches fire immediately. Ammunition stored in racks along the sponsons begins to cook off. The 75mm rounds detonate with enough force to blow the turret completely off the hull. If the tank is carrying smoke grenades, white phosphorus rounds, or gasoline for the auxiliary generator, the conflagration becomes even more intense. The temperature inside the crew compartment reaches 1200 degrees Fahrenheit in under 5 seconds. If the crew is lucky, they have perhaps 15 seconds to evacuate. Most aren't lucky. The driver and bow gunner must traverse the length of the tank to reach hatches. The loader must climb past the commander. In the chaos, in the smoke, in the flames, these maneuvers become nearly impossible. Some crews have taken to riding with hatches open, ready to bail out at the first sign of trouble. This creates its own problems. German snipers have adapted to this tactic with brutal efficiency. The men of the armoured divisions have already given the M4 Sherman a nickname. They call it the Ronson, after the cigarette lighter whose advertising slogan was, "Lights first time, every time." The British crews have a different name. They call it the Tommy Cooker. Neither nickname is used in official communications, but both are universally understood among the men who crew these machines. By late June, the casualty rates among American armor crews have become unsustainable. The 2nd Armored Division has lost 60% of its tanks in 3 weeks of fighting. Individual battalions report casualty rates approaching 80%. The 3rd Armored Division reports similar numbers. Individual companies have been effectively destroyed, rebuilt with replacement crews and tanks from the depots in England, and destroyed again. The psychological toll is immense. Tank crews are developing what would later be called post-traumatic stress disorder at rates comparable to infantrymen, despite being nominally safer inside armoured vehicles. The replacement crews arriving from England are younger, less trained, more frightened. They've heard the stories. They know what the Bocage does to Shermans. Many write letters home before their first combat mission, convinced they won't survive. The statistics suggest they're right to be pessimistic. Average life expectancy for a Sherman crew in the Bocage is measured in days, not weeks. Some refuse to button up their hatches, preferring the risk of small arms fire and artillery fragments to being trapped in a burning tank. This creates its own problems. German snipers, many of them veterans of the Eastern Front where such tactics were common, adapt quickly. They target tank commanders specifically, knowing that killing the commander often renders the entire vehicle combat ineffective. The Americans respond by having commanders duck down more frequently, but this reduces their ability to spot targets and navigate. It's a losing game. Every adaptation creates new vulnerabilities. The tactical situation has devolved into a grim mathematics that keeps Bradley awake at night. To advance 500 yards requires hours of preparation. Infantry must probe forward, trying to locate German positions without being cut down by machine gun fire from the impenetrable hedgerows. This is dangerous, slow work. A squad of 12 men might take an hour to advance a single hedgerow, and casualties are virtually guaranteed. Artillery must be called in, a time-consuming process that alerts every German unit for miles that an attack is imminent. The Germans, masters of defensive warfare after 2 years on the Eastern Front, use this warning time to reposition forces, to bring up reserves, to site additional anti-tank weapons. Engineers must be brought forward with explosives, attempting to blow gaps in the hedgerows while under fire. Bangalore torpedoes, pole charges, satchel charges, all are tried. Sometimes they work, often they don't. The root systems absorb tremendous amounts of explosive force, and even when a gap is created, it becomes an obvious choke point. German gunners simply train their weapons on the opening and wait. The first vehicle through almost always burns. The advance that should have taken days is taking weeks. General Omar Bradley, commander of the First Army, is under tremendous pressure from Eisenhower, who is under pressure from Roosevelt and Churchill, who are under pressure from a public that expects the victors of D-Day to be in Paris by Independence Day. Newspapers back home are asking questions. Why has the advance stalled? Why are casualties so high? What happened to American technological superiority? Instead, the Americans are stuck in fields named on no map, dying for hedgerows that appear on no tactical chart, fighting a kind of warfare that resembles the Western Front of 1917 more than the mobile armored combat they trained for in the deserts of California and the plains of Texas. The comparison to World War I is not hyperbolic. In some sectors, the rate of advance is slower than the Somme. The casualty-to-ground-gained ratio is approaching the worst days of Passchendaele. This is not the war anyone planned for. This is not the war anyone knows how to fight. The doctrine is wrong. The training is inadequate. The equipment, for all its sophistication, is ill-suited to the terrain. And every day the advance stalls is another day the Germans have to reinforce, to dig in deeper, to make the eventual breakthrough even more costly. Multiple solutions have been attempted, each failure adding to the growing sense of desperation. Engineers tried mounting bulldozer blades on Sherman tanks, reasoning that if the blade could push earth, it could push through a hedgerow. The blades broke. The hedgerow roots, some as thick as a man's thigh, woven together over centuries, were simply too strong. The blades were designed for earth-moving, not root-cutting. Someone suggested using flamethrower tanks to burn through the vegetation, to create paths through the hedges themselves. Tests were conducted. The vegetation burned, certainly, creating impressive pyrotechnics, but the earthen berms remained, and the fire and smoke merely created visual cover for German defenders, while leaving the tanks just as exposed during the crossing. Worse, the flamethrower tanks, with their volatile fuel supplies, became priority targets. The tests were discontinued after 2 flamethrower tanks were destroyed in a single afternoon. An engineer company spent 2 weeks developing an explosive device that could be mounted on a tank's bow, theoretically blasting a path through the hedge with a shaped charge similar to those used by the Germans. The device was complex, required careful preparation, and could only be used once before needing replacement. The first test destroyed the tank. The blast, insufficiently directed, reflected back onto the vehicle itself, stunning the crew and damaging the engine. The second test worked better, creating a respectable gap in the hedgerow. But the time required for preparation, the expertise needed for installation, and the risk of mechanical failure made mass production impractical. The idea was shelved. High Command is aware of the problem. Meetings are held in tents that serve as forward headquarters. Memoranda are written in triplicate and sent back to England, to Washington, requesting guidance, requesting resources, requesting anything that might help. The engineers of the First Army are tasked with finding a solution, given priority access to resources and personnel, but they're thinking too conventionally, too much by the book. They're applying engineering principles learned at West Point and MIT, looking for elegant solutions that can be mass-produced in American factories and shipped across the Atlantic. They're trying to go over the hedgerows or through them with brute force, with superior American industrial might. They haven't yet considered that perhaps the answer lies not in sophisticated engineering but in simple mechanics. They haven't considered that the solution might already be lying on the beaches, waiting to be repurposed. Enter Curtis Culin. Culin isn't an engineer. He has no formal technical training beyond what the Army provided. He isn't an officer, though he's been offered battlefield commissions twice and declined both times. His formal education ended with high school in Cranford, New Jersey, class of 1936. Before the war, he drove a cab, navigating the streets of Cranford and Linden, picking up fares at the train station, making small talk about the weather and the Yankees, collecting tips that sometimes amounted to more than his actual fare. He knew every street in Union County, every shortcut, every traffic pattern. He understood machines in the practical way of men who depend on them for their livelihood. When his cab broke down, he fixed it himself because he couldn't afford a mechanic. This pragmatic understanding of mechanical systems, learned through necessity rather than textbooks, will prove more valuable than any engineering degree. He enlisted in 1942, motivated by the same mix of patriotism and economic necessity that drove millions of Americans into uniform. The Army, recognizing no particular talent or education, assigned him to cavalry reconnaissance. By 1944 standards, cavalry means light tanks and armored cars, not horses. The 102nd Cavalry Reconnaissance Squadron operates M5 Stuart light tanks, fast and agile but thinly armored and undergunned. They're scouts, meant to probe enemy positions and report back, not engage in direct combat. But in the Bocage, everyone engages in direct combat. The distinction between front line and rear echelon has dissolved. Everyone is in range of something. Culin has seen combat. He's seen men die in ways that will haunt him for whatever remains of his life. He's seen enough Shermans burn that the image appears in his dreams, the dreams he has during the brief hours when exhaustion overcomes adrenaline enough to allow sleep. He's pulled wounded men from vehicles, their skin sloughing off in his hands, their screams cutting through the sound of battle. He's written letters home for men too badly burned to hold a pen, taking dictation while medics work frantically nearby. And on this particular afternoon in late June, watching another tank from his unit get picked off while attempting to cross a hedgerow not 200 yards from where he sits, something inside him snaps. Not a breakdown, not panic, but a kind of clarity that comes from absolute desperation, a moment when all the irrelevant considerations fall away and only the essential problem remains. Men are dying. Tanks are burning. The solution isn't coming from headquarters. If something is going to change, it has to change here, now, at this level. The problem, Culin realizes, isn't the hedge itself. The hedge is just earth and roots. Tanks can handle earth. Tanks can break roots, given the right tools. The problem is the angle of approach. The Sherman's designers never anticipated this terrain. Why would they? The tank was designed in 1941 based on combat experience from North Africa and anticipation of European warfare. Everyone expected France to look like the maps, like the open country around Paris, like the tank country of Poland where the Germans had demonstrated the effectiveness of mobile armoured warfare. Nobody anticipated that the Allies would have to fight through medieval farming country where property boundaries hadn't changed since the 100 Years' War. The vulnerability of the belly armour was an acceptable trade-off for speed, for the ability to mount a 75mm gun that could engage German armour at reasonable ranges, for the logistical simplicity of the Sherman's design that allowed it to be mass-produced in numbers that overwhelmed German production. But here in the Bocage, that trade-off is killing men by the dozen every day. What if, Culin thinks, you didn't climb the hedge? What if you cut through it? The idea seems almost childishly simple once it occurs to him. Why try to go over an obstacle when you can go through it? Mount blades on the front of the tank. Steel teeth that could bite into the earthen berm, could saw through roots, could allow the tank to bull its way through the hedgerow while remaining horizontal. Keep the belly armour protected. Keep the main gun level and ready to fire the moment the tank breaks through. Turn the Sherman into something like a giant hedge trimmer on tracks. Use the tank's weight and power not to climb but to cut. Culin shares the idea with his commanding officer, Captain James DeBolt, during a lull in operations. DeBolt, a former high school teacher from Iowa, has the good sense not to dismiss it immediately. He's lost too many men to dismiss any idea, no matter how unconventional. Within hours, the concept reaches Lieutenant Colonel Arthur Worrell, commanding officer of the 102nd. Worrell is intrigued. He's desperate. His unit has been hemorrhaging tanks and men since landing at Utah Beach. The replacement rate can't keep up with the casualty rate. Any idea, even a crazy one from a cab driver turned sergeant, deserves consideration. He gives Culin permission to experiment. More importantly, he gives him time, resources, and protection from the military bureaucracy that might otherwise stop an unauthorized modification to military equipment. The first problem is materials. Where do you get several tons of steel suitable for blades when you're fighting in rural France? When every pound of steel shipped from England is accounted for, when requisitioning anything through proper channels takes weeks of paperwork? Culin looks around. Everywhere in Normandy, the Germans have left reminders of their 4-year occupation. Most relevant to Culin's needs are the beach obstacles, the steel anti-invasion barriers that Rommel's engineers planted along the Atlantic Wall in the months before D-Day. Specifically, the Czech hedgehogs. These welded steel structures, each made of 3 pieces of heavy steel beam joined at perpendicular angles, were designed to rip the bottoms out of landing craft attempting to reach the shore. They were effective on June 6th, but only for the first few hours of the invasion. Once the beaches were secured, they became simply obstacles to logistics, impediments to the flow of supplies and reinforcements. Thousands of them still litter the beaches, no longer needed now that the Allies control the coastline. They represent tons of high-quality steel, already cut to convenient lengths, already hardened by German metallurgists, perfect for Culin's purposes. The irony is not lost on anyone. German steel, designed to kill Americans on the beaches, will be repurposed to kill Germans in the hedgerows. Culin requisitions a truck, drives to Utah Beach with a work detail, and returns with a load of salvaged Czech hedgehogs. The MPs at the beach initially question whether he has authorization to remove the obstacles. Culin shows them his orders from Colonel Worrell. The orders are vague, deliberately so, mentioning only recovery of salvage materials for experimental purposes. It's enough. The MPs wave him through. By evening, Culin has 2 tons of German steel sitting beside his tank. Working with a borrowed welding rig and help from the unit's maintenance crews, men who in civilian life were auto mechanics and iron workers and farm equipment repairmen, he begins fabricating his device. The design evolves through trial and error, through practical experimentation rather than theoretical calculation. The first prototype uses 4 prongs, like a giant fork, welded to a horizontal bar that bolts to the bow of the Sherman. Tests against a section of hedgerow show promise, but the prongs are too far apart. The tank breaks through, but unevenly, creating a gap too narrow and rough for safe passage. The second prototype uses 6 prongs, spaced more widely across the front of the tank. Better, but the angle is wrong. Too steep, and the prongs simply climb the hedge like the tank itself would. The tank tilts forward, defeating the entire purpose. Too shallow, and they don't penetrate deeply enough to cut through the root system. They scrape across the surface, pushing the hedge aside momentarily but not creating a permanent breach. After 3 days of work, of cutting and welding and testing and modifying, Culin has a device that looks almost comically simple. 6 steel prongs, each roughly 3 feet long, sharpened to wedge-shaped points, welded to a steel crossbar that matches the width of the Sherman's bow, the entire assembly weighing approximately 400 pounds, bolted to mounting brackets welded directly to the hull. It looks like something a medieval siege engineer might have designed. It looks crude, improvised, almost amateurish. The welds are functional rather than beautiful. The steel is pitted and scarred from its previous life as beach obstacles. There's no paint, no markings, nothing to indicate this is an official piece of military equipment. It looks like exactly what it is, a desperate solution improvised in a combat zone by men who don't have time for proper engineering. It works perfectly. The test occurs on June 27th, in a field 3 miles behind the front lines that has been designated for equipment trials. Colonel Worrell arranges for a demonstration, inviting officers from adjacent units, from division headquarters, anyone who might have the authority to authorize wider implementation if the device proves successful. A Sherman fitted with Culin's device approaches a hedgerow at standard speed, approximately 8 miles per hour. The driver, Corporal Robert Miller from Tennessee, has been briefed but is visibly nervous. Nobody knows if this will work or if the tank will simply become stuck, exposing him to whatever simulated enemy forces are hiding beyond the hedge. The prongs bite into the earthen berm with a sound like tearing canvas amplified 1,000 times. The tank's engine strains, the transmission downshifting automatically as resistance increases. For perhaps 3 seconds, the outcome is uncertain. The tank could stall, the prongs could break, the entire assembly could tear loose from its mounting brackets. But the tank was built to push 33 tons through mud and over obstacles. This is just more resistance, more load on an engine and drivetrain designed with generous safety margins. Root systems that have been growing for centuries, root systems that have survived plows and shovels and axes, snap like twigs under 33 tons of American steel and determination. The Sherman punches through the hedgerow without tilting, without exposing its belly, without pausing. The passage creates a gap roughly 12 feet wide, cleanly cut through earth and vegetation. On the far side, the gun mantlet is level, the driver has a clear field of view through his periscope, and the tank is ready to engage any target immediately. The entire breakthrough takes 7 seconds. Officers watching the demonstration stand in stunned silence. They've been wrestling with this problem for 3 weeks. The best minds in the engineering corps, men with degrees from the finest technical schools in America, have proposed complex solutions involving hydraulics, explosives, specialized equipment that would take months to design properly, months more to manufacture in factories back in the United States, additional months to ship across the Atlantic. And a sergeant from New Jersey, a man whose technical education consists of keeping a 1937 Chevrolet cab running through 6 New Jersey winters, has solved it with scrap metal and a welding torch in 3 days. Word spreads through the command structure with the speed of wildfire in dry grass. By evening, officers from the 29th Infantry Division are requesting demonstrations. By the next morning, representatives from the 9th Infantry Division have arrived. Bradley himself, commanding general of the entire First Army, demands a demonstration within 48 hours. He arrives in a jeep, accompanied by his chief of staff and several corps commanders, to watch 3 modified tanks punch through a series of hedgerows that would have taken a company of infantry and a platoon of engineers hours to clear using conventional methods. He sees immediately what this means, not just tactically, at the level of individual tank battles, but strategically, at the level of entire armies and campaigns. The Bocage, which has functioned as Germany's second defensive wall after the Atlantic Wall itself, which has allowed outnumbered German forces to hold against overwhelming Allied superiority, has just become obsolete. The advantage has shifted. The Americans can now use their armor the way it was meant to be used, in mass, with speed, exploiting breakthroughs before the enemy can react. Bradley makes a decision that will alter the course of the Normandy campaign and possibly the entire European war. Every available maintenance company, every mobile workshop, every welder in the First Army is to begin producing these devices immediately. Not for testing, not for evaluation, for immediate combat deployment on every tank in the theater. The ordnance companies receive orders to strip every German beach obstacle they can find, every Czech hedgehog, every piece of scrap steel suitable for fabrication. Produce as many devices as possible as quickly as possible. Quality control is secondary to quantity and speed. The official designation becomes Armored Hedge Device, T3, the T indicating temporary or experimental status. The men simply call it the Culin Cutter, or the rhinoceros, because a Sherman fitted with the steel tusks resembles nothing so much as an angry rhinoceros about to charge. Bradley's decision includes one additional element: secrecy. German intelligence is still functional despite Allied air superiority, despite the devastation of the German communications network. The Germans still have agents in France, still intercept radio communications, still interview prisoners. If German intelligence learns that the Americans have solved the hedgerow problem, they'll adapt their defensive positions accordingly. They'll move their anti-tank weapons back from the hedgerows, creating killing zones in the fields themselves. They'll mine the areas behind hedgerows. They'll develop new tactics to counter the new American capability. Every day of German ignorance is an advantage, so the modifications are conducted in rear areas, away from the front lines. Units are rotated back for maintenance in a carefully orchestrated schedule that disguises the true purpose. Security is emphasized. Crews are briefed not to discuss the modifications in letters home, not to mention them on radio communications that might be intercepted. The Germans must learn about the Culin Cutter the hard way, by experiencing it in combat when it's too late to prepare an effective defense. The logistics of the operation are staggering. The First Army at this point numbers approximately 500 armored vehicles requiring modification, 437 M4 Sherman medium tanks, 58 M5 Stuart light tanks, and assorted specialized vehicles. Each device requires approximately 400 pounds of steel, carefully cut and shaped. That's 200,000 pounds of material, 100 tons, all of which must be salvaged from German obstacles, transported to workshops, cut to specification, welded into assemblies, and installed on vehicles. Each installation requires roughly 8 hours of work by skilled welders. That's 4,000 man-hours of welding alone, not counting cutting, fitting, drilling, mounting holes, and all the ancillary work. And it must be done in secret, which means it must be done away from the front lines, but not so far back that transportation becomes an issue. It must be done quickly, before the Germans realize something is happening. And it must be done well enough that the devices won't fail in combat, because failure means death. The workshops work around the clock in shifts, welders and mechanics sleeping in 4-hour rotations. Sparks fly through the Norman twilight as hundreds of welders cut and shape German steel that just weeks ago was under water at high tide, covered with barnacles and seaweed. The sound becomes so constant that infantrymen sleeping near the mobile workshops complain they can't rest. The work continues anyway. Bradley has given them a deadline. Operation Cobra, the massive breakout offensive that's supposed to rupture the German lines and begin the race across France to Germany, is scheduled to begin in late July. Every tank must be modified before then. Every tank must be ready to exploit the breakthrough. There are no exceptions, no excuses. The German intelligence apparatus, still functional despite the Allied air superiority and the systematic destruction of the German communication network, notices something unusual. American armored units have pulled back from the front lines for maintenance. Multiple divisions, normally committed to holding or pushing the line, have rotated to rear areas. German aerial reconnaissance, increasingly rare due to Allied fighter dominance but not entirely absent, photographs tank parks that are unusually full. Radio intercepts mention maintenance issues, mechanical problems, replacement parts. This is interpreted as a sign of mechanical breakdown, of the Sherman's notorious unreliability finally catching up with intensive combat operations, of an American offensive delayed by logistics rather than German defensive success. The German commanders at 7th Army headquarters congratulate themselves. Every day the Americans spend repairing their equipment is another day to strengthen defenses, to bring up reserves from the interior of France, to prepare for the inevitable offensive. They don't know that they're not witnessing maintenance problems. They're witnessing the largest rapid modification program in armored warfare history. A program that will render their entire defensive strategy obsolete in less than 72 hours. By July 15th, more than 500 Shermans have been fitted with Culin Cutters. The modification has spread beyond the First Army. Patton's Third Army, preparing for its own role in the breakout, still waiting in England for the signal to deploy, demands the devices for its armour. Engineers are sent to explain the fabrication process, to train Patton's maintenance units, to ensure that when Third Army deploys it will have the same capability. The British hear about the American invention through the inevitable channels of inter-allied cooperation and competition. Montgomery's staff examines captured examples, takes measurements, conducts their own tests. Being British, they cannot simply adopt an American design without modification. They insist on changes, slightly different angles on the prongs, a different mounting system, British standard bolts rather than American. They insist on calling it the prong device rather than acknowledging Culin by name, a bit of bureaucratic pettiness that annoys the Americans but ultimately doesn't matter. What matters is that by late July, virtually every Allied tank in Normandy has the capability to breach hedgerows at will, but the proof, as always in warfare, comes not in tests or demonstrations but in actual combat against an enemy who is trying to kill you. July 25th, 1944, 0900 hours. Operation Cobra begins with the largest aerial bombardment in support of ground forces yet attempted in history. 1,500 heavy bombers, B-17 seconds and B-24 seconds from the 8th Air Force, drop approximately 4,000 tons of high explosive on a section of German line 5 miles wide and 1 mile deep, an area of approximately 5 square miles. The bombardment lasts 2 hours. The earth itself seems to revolt against the human beings unfortunate enough to be underneath. Trees are uprooted, hedgerows are obliterated. Buildings simply cease to exist. The German units in the target area, primarily elements of Panzer Lehr Division, one of the Wehrmacht's elite armoured formations, are devastated. Entire companies are destroyed. Communication networks are severed. Command and control breaks down. When the bombing stops, the American armour moves forward into what should be a shattered, disorganised enemy. This time, it's different. The Shermans don't stop at the first hedgerows outside the bombardment zone. They don't wait for engineers or infantry or artillery preparation. They don't probe cautiously for German positions. They simply lower their steel tusks and charge. The sound, according to accounts from both American and German soldiers who survived the day, is unlike anything heard before in warfare. Not the familiar squeal of tank treads on pavement or the roar of engines under load, but a grinding, tearing, almost organic sound of ancient root systems being ripped from the earth. It sounds, several accounts agree, like the earth itself screaming. Hedgerows that have marked property boundaries since the time of Charlemagne, hedgerows that survived the 100 Years' War and the wars of religion and the French Revolution and the Franco-Prussian War and the First World War, disintegrate under the assault of American armour fitted with German steel. The German defenders, dug into positions that have proven nearly impregnable for 6 weeks, positions that have cost the Americans thousands of casualties to advance mere hundreds of yards, suddenly find themselves facing an enemy they can't contain using established doctrine. The carefully prepared killing zones, the pre-ranged firing positions registered with every anti-tank gun and mortar, the interlocking fields of fire that allowed outnumbered German forces to hold against massive American superiority, all become irrelevant when the Shermans simply punch through the barriers that defined those positions. The defensive geometry, so carefully constructed, collapses. A Panzerfaust team, 2 grenadiers with 3 rockets between them, sets up in their carefully prepared position to ambush a tank at a hedgerow crossing. They've done this successfully a dozen times. They know the timing, know exactly when the American tank will be most vulnerable. The tank doesn't use the crossing. It makes its own, 40 yards away from the prepared position. The German soldiers find themselves behind the American armour, their ambush position turned into a trap for themselves. They have perhaps 5 seconds to react before American infantry following the tanks spot them and open fire. The psychological impact on German forces is profound and immediate. The Bocage has been their equalizer for 6 weeks, the terrain feature that allowed outnumbered and outgunned units to hold against massive American superiority in men and material. A platoon of German infantry with a few Panzerfausts could hold an entire American company for hours in the Bocage. Battalion strength positions could stop division-level attacks. The terrain did half the defensive work, allowing German commanders to achieve tactical effects far beyond what their force ratios would suggest. Suddenly, catastrophically, it's gone. The Americans are everywhere, moving through terrain that should be impassable, appearing in fields that should be isolated, encircling positions that should be secure. The defense begins to crack, not through overwhelming force, though force is certainly applied, but through the sudden obsolescence of defensive doctrine. German commanders who have fought brilliantly for 6 weeks, who have managed their limited resources with great skill, who have inflicted casualties far beyond what American planners anticipated, find that their expertise no longer matters. The rules have changed. The Americans have changed them. And there's no time to adapt. Within 72 hours, the American advance penetrates 25 miles beyond the front lines that had been static for 6 weeks. The German 7th Army, which has held the Allies to a grinding stalemate since D-Day, disintegrates. Entire divisions are encircled in what will become known as the Falaise Pocket. The roads leading away from the front become clogged with retreating German forces trying to escape the suddenly mobile American armour. The retreat becomes a rout. The rout becomes a massacre. The Falaise Pocket, one of the greatest encirclement battles in history, one of the most decisive Allied victories of the European War, becomes possible only because the Americans finally broke free of the Bocage using a device invented by a cab driver with a welding torch. The numbers tell the story with brutal clarity.